Hello guys, welcome back. In this video, what we are going to do? In this video, we will achieve stock prediction using ML model. Let's have a question. To achieve this, what we require? Do I require first live data of my current stocks? Yes, we require that. Okay. Anyhow, I'll try to get the live data. After that, I will take past history and till today I want to take what are the stock prices and what are the closings, what are the starting high price, what is the lowest price, and what is the closing value or adjusted close value of that stock for that particular day. For every day I want to take that data. Then after taking that data, in order to what we are doing, we are predicting the stocks for future. To do that, first I need to analyze whatever the data that I got, right? Yes. So that also we will do. That is, we will visualize our data. After visualizing the stocks, what I need to clearly observe day to day how much return I will get. That I need to observe, right? Yes. To observe that, we will consider three metrics. One is absolute returns, and the second one is log returns. Why? Okay, first one is absolute returns. We will use to see exactly what is the difference between the current day to previous day stock price, so that we will understood. And we will also analyze one more thing, that is absolute returns, where those are really useful for tackling actual dollar movement or actual currency movement in a single asset. That is absolute difference between simple difference in our price that we can able to observe. Whereas why we choose percentage return, like the ratio absolute, other than absolute, like pt minus, like previous day price to today price, what is the difference? That is the absolute difference. That is simply for identifying the difference between the price of stock. Whereas we use a percentage return, it is a normalized measure relative to previous day stock price. So that is best for daily returns, like performance comparisons across our whole asset. So that percentage returns will be very helpful for us. And we will also take, or we'll also consider one more return, that is log return, which is basically for continuous compounding and time additive is the main feature of that returns. Log returns, if we consider, those are mainly preferred in financial models, especially when dealing with continuous returns or volatility. For one day, or you can say, let's take today. Today some high expectation stocks are there, that is, let's say, for particular stock, the expectation of buying that stock, or you can say the highest expectation of buying that stock is there, and the lowest expectation of buying that stock is also there. And at the end, while closing of the day, the stock price will be leading to a particular point. That means either the highest expectation may be decreased, and that highest expectation may be reduced to close price, or the lowest expectation will be increased and move to the close price. So either any one of the thing may happens in real time, or both the things may happens in real time based on the closing price of the stock, that we will understood by using a log returns. After visualizing in detail in such a manner by using such returns, we will create, we are going to create an ML model. For what? For predicting the future values. To predict the future values, we will create our ML model and we will test our ML model with some data. Then we will compare that data with the actual data. We will compare the predicted data with actual data to identify how much accurate our model is performing. So this is all the main agenda of this video. So these are all the things which are covered in this video. For this demo, for this lab, I've already created a Jupyter notebook. Either you can create or launch a Jupyter notebook in your Colab. That is for free. That is provided by Google. Or directly install this Jupyter lab or notebook on your systems and you can just open that in web so that it will open like this. Now, first, what I want to do. So first, what is our task? Our task is to get the stock data. So how to get this? To get this, we have multiple methods. So like we have Pandas Data Reader, Panda Pandas Data Reader dot data reader method. We have this method. We can use this method to get the live data, or we have also one more method, that is yFinance. So by using this method also we can able to get the live data. We can also have NSC py dot yFinance dot download is the method, and we have NSC dot get history. Like this, we have multiple methods are there to get the live data of stocks. Now, for this demo, we are using this. So these all are, so whatever the methods that I am telling now here, these all are free. That is, they do not require any API keys. Whereas we also have some more methods where they require some API keys for accessing the data. So they are best for getting a live data. Whereas these are best for demo purpose or for experimentation purpose. Now for this demo, I am using this yFinance dot download method to get that. So now I am using this yFinance dot download because it works well. And this is also I want to show you at the end so that you can able to get how to get the data from this. First, let's install all the dependencies which are required for me. I want to show you these two methods. So the dependencies that I require is yFinance. I'm also mentioning the version because so in sometimes if you are installing the dependencies, the version may varies. That conflicts you to do this or to continue this experiment. So now I'm installing all these like yFinance with this version, NumPy with this version, number expression with this version, and Pandas with this version. And to run this, you have multiple ways like just click on run so that it will run, or just simply press shift and enter if you are using Windows. Currently I'm using Windows, so that's why I want to prefer shift and enter. So every time I'm executing this, after this cell got executed, you can see like this numbering will be visible to you. Okay, this cell got executed. Now we can able to import finance, yFinance, or we can able to import pandas as well. Like this pandas data reader, we can able to import as well. So let's first I want to show you this by using this pandas data reader how to get the stock data. First import that pandas data reader as PDR. Now this was imported and PDR dot yf underscore override. So if there will be any overriding is there, so it's not this is yf dot pdr override. So that is a, so if there will be any overrides in pandas data reader, then we are using this yf. What is yf, sir? I'm assuming yf as yfinance. yfinance as yf I'm using. And so let's import the pandas as well. Let's import the pandas as pd and let's continue. Now you can see I do not get any error. So whenever there will be a override in pdr, like pandas data reader, we are using yf. Okay. Now first I want to use this pdr pandas data reader to get the stock data. So pdr dot, so what is the method you use? Data dot data reader. So this is the method I want to use to get the stocks data. Let's say I want to get TCS stocks data. In particularly India, I want to get the TCS stocks data. So let's say if you are not specifying the country like India, then you can directly provide the name like this, and you need to provide what is the start date. From what start date you need the data from, and from till what date, till what end date you are expecting the data. So to specify date and time, I am importing date and time. I'm importing date time from this date time itself. So I have this library available in Python. By using that date time method, I can able to define what year, from what year, what month, what date I require my stocks data, and till what year, what month, and what date I require my stocks data. Let's say I want 2023 from 3 and 1 till today. That is 2024, and today date is this is the 12th month, and today date is 28. So I'm mentioning 28. Okay, let's, so to get this data, I'm just pressing shift and enter. Since I'm using Windows, you can see till 27 I got the data. That is this is the end time, right? So 28 is the end time. So that's why I'm getting till 27. You can observe. Okay, today's stock is not closed, I think now. So that's why we are getting only till 27. So based on this data, can I able to predict today's closing? Yes, we can able to predict that as well. So let's take up to 28. So till yesterday I got the stock data, like the date and their respective opening. What is the highest value of their expectation of stock, and lowest value of expectation and closing value of the stock price, and adjusted closing and the volume of those stocks. So though these details are available for us right now. So one more thing I want to mention, that is if you are getting the stock related to India, then .ns is the best thing that you need to mention, or .bo, Bombay Stock Exchange, or NS, that is a National Stock Exchange, NSE. So that you can mention. So that is a best practice. So I am mentioning this. Okay, I think now you understood by using this, that is a PDR, Pandas Data Reader. How can you able to get the stock data till today? And now I want to show you by using yfinance, how can you able to get the stock data till today. So I don't want to store this. So again, by using yfinance, I want to get the data and store the data in d variable. So first let's get the data. Yfinance or yf, right? We imported that as yf. So I'm using that yf dot download of, So what is the stock or what is the symbol of that stock? That is a TCS dot NS is the stock symbol. Where can I able to get these symbols, sir? You can able to get these symbols from NSE Stock Exchange or Bombay Stock Exchange. And what is the start time? So let's say I want the start time. So I want to mention date time of I want the stock from 2023 1 and 1 till end. What is the end date? Date time I'm mentioning here, that is 2024 till today, that is 28. I'm getting this. I want to show you the date as well, so that's why I'm writing this. And so let's shift and enter. So now you can see till today I got the stock data, stock prices data. Since this is a TCS data, I want to store in a variable like a TD. Then at the end I want to display, so that's why I'm using TD at the end. So not only TCS data you will get, you can able to get the other data like Wipro you can get. So just replace the symbol or stock name, that is Wipro. So that's it. Now you can see this is the Wipro related data. So not only this, you can able to get any stock related data. In real time, you might need to compare multiple stock prices. So during that time, you might need to take multiple data sets and need to compare them. So I think in TD, okay, in TD now the updated data is Wipro related stocks data. So in TD I want to store this TCS data itself, and Wipro data I want to store in WD. Okay, again I'm displaying TD. This is the Wipro data, and let's take one more, that is Infosys data. So ID. So that Infosys symbol is INFI. So how do you get this INFI, sir? So simply very simple. That is I just opened my Google website, and there I opened this NSE National Stock Exchange, National Stock Exchange, and there I searched for this. So here I searched for Infosys. So you can see the symbol INFI, right? So that's what I'm using. You just open it so that you can able to get that particular related name or symbol of that stock. I'm just opening this, and so INFI, I'm just running this cell so that, yeah, so that Infosys related data also visible to me. Now I successfully get that stocks related data. Now I want to visualize that data. To visualize that data, so you need to use matplotlib. So I'm just using matplotlib. So for that I'm importing matplotlib dot pyplot as plt simply. And first I want to know, I want to see what are the symbols I have. So what are the symbols I have, that what are the styles I have, that I want to see. So that's why I'm writing this summary. So might I'll get error, okay, that's okay. Styles dot context I need to place. So I want to see the styles related. The exact method is plt dot style dot available. So it will show you the exactly what are the methods we have. You can see we have multiple methods. Among these you can see I have the seaborn method. I want to use this seaborn method in order to see, or in order to plot my data, whatever the data I have, that I want to plot in this way to visualize that. So I want to use that, I just commenting this. So with plot dot style dot context of seaborn. So with this style, I want to plot. So what I want to plot? plt dot plot of what data I am expecting to plot. Let's say I want to plot TCS data that is stored in TD variable, so I am providing TD. And now I just clicking on shift and enter, or okay, so I am just clicking on shift and enter. So styles is not there, plot dot style dot context. So now you can see from what date till what date I provided the data. So till that date I am getting the graph, right? Yes. So in TD or in, so this is the TD related data, that is TCS related data. Now I just want the top or the first 10 records, the first 100 records I want to see. So if you want to visualize only the first 100 records, you just use the head function. How many you want to visualize? 100. So I provided that. So first 100 records related visualization you can able to see now. Let's say I want to see the last 100 records. Then you can use this tail method to get the last 100 records. You can see 20, 25 till 1. Now let's say I want to see particularly related to. So here you can see multiple data are there. So let's see only the last 10 records. So the last 10 records are look like this. So the graph will be looks like this. So in my graph, I will get a plot for this open values, high values, low values, close values, adjusted close values as well as volumes values as well. But what I require, I want to see only the closing value of that stock. So to see only the closing values of that stock, you need to define that. So here I am providing this close. To see only the closing value related plot, this is the closing value related plot. Now, so not only TCS data, I want to see other data as well. I want to see other data as well in the same plot. Like I want to see the Wipro data. So that's why I'm providing Wipro data dot tail. Tail of last 10 records is enough for me. That to closing values I'm expecting to see. But I cannot able to separate them. Like what is Infosys, what is Wipro. So for that I'm providing a label that is this is related to TCS closing close TCS close value, TCS stock price, TCS stock close value, and I'm providing the label for this as well, like Wipro stock close value. So that I'm providing here. So still they are not visible. So you just write like a plot dot legend. So now you can able to observe this is related to TCS and this is related to Wipro. So don't consider the names. So just consider two stocks. Like this is the stock one and this is the stock two related data. So like that you can able to consider, don't compare the companies or anything. So let's also see the third company. So plot of, so IF or ID Infosys data, tail of I want to take last 10 records and I want to see the close value and I want to provide the label as well for that, like stock 3 close value. Okay, so now you can able to observe three stocks related closing values are visible to us, right? Yes. So now what we did till now is we just taken the data, or we just install whatever the dependencies that we require to get the data, then we used the methods to get the data. So those things we did and we visualized the data, that whatever the data that we get, like the top 10 or top 100 or last 100 records we visualized, that is from today to past 100 days. So whatever the stock prices variations, those are visible here. So that we visualize it now. Now we want to define or we want to identify or find returns. So what are the returns? That how we can able to identify. For day to day returns I want to identify. If you want to identify day to day returns of any data frame, since this is a currently whatever the data that we have, the three datas, those all are data frames. Like you just write this a TD, that is nothing but a data frame. That is TCS data is nothing but a data frame. Till now we have only these columns. So for this closing value, I want to find this the difference like percentage change. Now I am defining one more column that is a percentage change, that is PRCHANG. Day wise percentage change, so that's why I'm writing this PRCHANG and I'm defining that percentage. We have, so I'm just taking this close values of my data frame, that is a TD of this close will provide me only this row related data, and dot PCT underscore change, so it will provide me the percentage change of that data. And let's print that data again. So now you can see the percentage change will be visible, whereas the first value will be not a none, that is a not available value. That means why we get like this? The reason is, for this the previous closing value is not there. You can observe that. So that's the reason there is no value available here. So if you invest this day and if you withdraw in this day, this is the percentage. This is the percentage of increased value. This is the percentage of increased value. Sometimes in some days there will be a negative returns also happens. So that is a negative percentage of returns. So this is the method that is already available for us in pandas. Since if you are using a pandas data frame, so that's why I'm using this method. Instead of percentage change, can I say it's a percentage of returns? Yes. So it's a percentage of day percentage returns, or previous day comparison of previous day to today percentage returns is this. So day to day percentage returns. DD. So let's consider DD as a day to day percentage returns. Now I'm just rerunning this so that this data will be stored. Now I want day to day log returns as well. So TD of day to day log returns. So that I want to find. So to find this, there is no method for us available in pandas. So that's why I'm importing a numpy as np, and I want to use that np dot log function to get the log. And for what we are performing the log for this low value. So that's why I'm providing that data frame, that is a TCS data of that close value I'm providing. And for that log data is we get here, and the difference we need to get right. So for that also I'm providing this log of TD of this close data dot shift. So it will provide me a shift of 1. Since we mentioned 1, a 1 shift, that is from this row till end I'll get the records. So like that it will be happen. Now I just want to, so before entering, after doing this I want to print this, so that's why I'm providing this CD. Now you can see for this also we'll get that data, right? Yes. So day to day returns, percentage change, day to day returns, and I also get this day to day logs. I don't want this percentage change because that is that and this day to day returns are same. So that's why I'm dropping this TD dot this percentage change. I'm dropping TD of TD dot drop of, so what you want to drop, that is this percentage change. So this I want, I think I need to mention the correct spelling. So what happened, percentage change does not found in the access. So I think it is considering here. We need to mention the axis as well, like drop this column with axis is 1. So that particular axis we are dropping. Now we can display the data frame so that row will be dropped right now. Okay. Now we will get a day-to-day percentage returns and day-to-day log returns also we'll get right now. Apart from these two, I want to see the interest. Like, so for this data, what is the interest? Like people interest, how it is changing, interest change. So that also I want to see, like how I can able to predict this. I can able to predict this by using this highest interest to lowest interest difference by this close value. So highest interest is nothing but this high, whereas this lowest interest is nothing but this low, and so the division with this closing value will provide me the absolute or the percentage of this interest change, and I'm providing again into 100 so that it will provide me the percentage. Now at last I want to print this interest values as well. You can see this is the interest. So initially the interest will be like this. So and that will be changing in this way. So in the second day it is increased, and the next day that was a slight decrease, and it will be 1 is the interest rate. So now in the previous day, exactly if we compare the yesterday, it is 0.8. So before that day it will be 1. So like this the interest will be the people's interest or expectation, or the people's related stock buying or selling. So that interest will be like this. So this is the rate of that particular interest. Okay, now we have all the required columns. So I think I need to write correct names. So let's redrop this, and like whatever the change in name that I provided, that I expecting to redrop. I want to drop this name or this column and recreate this column. You can see, yeah, correct column is created. Now I want to remove this. Okay. So now we have all the columns that we are expected. If we observe here, some null values are there. That is a not a none. That values are there. That means we need to remove, or we need to remove those null values, or we need to impute the values there for null. So currently I'm importing. So for that I'm importing the imputer from sklearn dot experimental. So first we need to enable that, enable imputer, iterative imputer. Then from sklearn dot imputer, I want to import this iterative imputer. Now I want to create this imputer, so that's why I'm creating this iterative imputer, and I want to create the X data, that is the input data I want to create, or the imputed data frame. Since this is a TCS data frame, I want to remember like a TDF. Imputed TDF is nothing but, so imputer dot fit transform. So this is the method that I'm using to impute this data. So what data I'm imputing? TD, that is TCS data. After imputing, I want to print that imputed data frame. So now you can see this is how the imputed data frame will be look like. But how I want to see this imputed data? I want to see the same like a data frame. To see this data as a data frame, you need to use this pd dot data frame. So in the previous steps, I've already imported pandas as PD, so that's why I'm using this PD dot data frame method in order to import that as a data frame. Now you can see the data will looks like a data frame. The total number of records and rows and columns are same here. You observe, and if you observe, there are any null values. Currently, there are no null values. You can clearly observe that there are no null values, and the columns I want to provide, there is no column names. Columns I want to provide like a list of this td values. Those are nothing but my column values. I provided those. You can see I provided the column names, right? Yes, I provided the column names. Now my data set is ready. I want to take a model and train a model. So for that, I'm just expecting to take this data first, like input and output values. First, let's take the output. What is the output that I am expecting? I am expecting this adjustable closing value. Other than this closing, why I am taking this is, so at the end of the day, this is the adjusting value. This is the closing value of the day, and this is the adjusting value. That means that this, if I take this adjusting closing value, then it is very accurate for me for next day predictions, for future predictions. So that's why I'm taking this. So what is this data? This is the imputed table data or thesis data of this adjusted closing value I'm taking and storing in y variable. So at the end I want to print this to show you that data. So this is running. So wait for a moment so that we can able to see that result. Now you can see this is the y related data that is the outputted, and now I want x data like the input data. That is you can see this is not normalized data, like large number of values are there. For each volume there is a large data is there, like adjusted values are somewhere, and this day to day percentage returns are in between 0 to minus 1, that is 1 to minus 1, whereas these volumes are in between so I think large values are there. So we are expecting to normalize this. So unnormalized data, let's take it first. Unnormalized data I'm taking from this imputed TCS data. So dot. So how to get those? By using this drop method. I'm dropping only this adjusted close as well as this closing values. Close I want to drop and adjusted close I want to drop. So both are having axis 1. So only one axis for both. So that's why I'm dropping those. At last I want to print that unnormalized x values as well. So these are the uh, columns that are considered for the x. So for these inputs, these are the outputs. I want to train a model with these inputs to expect these outputs. So first I want to normalize this data, x values, so that the calculation will be easy. To normalize this from sklearn.preprocessing, I want to import standard scalar, and I'm creating a scalar, standard scalar of, and I want to use this scalar to transform this data, like fit transform this x underscore unnormalized. unnormalized data, and I'm storing the result of normalized data in X, and at last I want to print. So I think this is not a data frame, this is just an numpy array. I want to make it data frame. So I'm using this pd.data frame, and I want to mention the column names as well. So let's run it. After that we can provide the column names. Now we'll provide the column names. Columns is equals to list of, so what are the columns which are present in X unnormalized data? So those are the list of column names that I have provided. Yes. Now I want to take this X value. That is, I want to take this X and Y values to split this particular data into training and testing. So from sklearn dot model selection, I want to import train, test, split, and I want to use that method to this train test split method I am using to split this X and Y values with a test size, that is this test ratio, that is 0.3, test data set size is 0.3, and I want to store the result in X train and X test for storing X train and testing data set, and Y train and Y test I want to use for storing training and testing data set for Y. Then I simply want to create a model. So to create a model, since this is a classification related problem, or since this is a recursion related problem, I'm just importing a linear model, that is a linear regression, and creating this linear regression model by using this LR. To this LR variable, I am assigning that model, or just provide your model name like a model, and so I'm just assigning this linear regression algorithm. So now just algorithm load into this model. So in order to train this model, just use this fit method and provide this training data set of X values and Y values, so that your model will be trained, and I'm storing in a H variable. So if you print this H, you can able to see the trained model, or you can just type the model so that you can able to see that model. So this is normalized, I want to mention that as well. So while creating this model, I want to say that normalize is equals to true, and now run it. So now the normalized data is provided to this model. Okay. Now I want to use this model to identify the score, or identify the evaluate this model. I want to evaluate this model how good it is performing. To evaluate this model, I want to import R2 score. Since it's a regression based model, I want to import this R2 score from sklearn dot matrices. I want to import this, and so by using this R2 score, I want to provide whatever the Y test data. I want to, this is the original data that is need to be predicted, but what model is predicting? Y predicted is nothing but the model predicted value. I want to find that predicted value for the model. So I'm using the model dot predict method to predict the value for Y test data, and predict, not Y test, X test is the data that I want to use to pass to my model. So that I am passing to predict the Y value and predicting that and printing that value here. I'm just running this. I don't think this E is there. Or so the spelling mistake, that is METRICS. Yeah, now it is predicting the score, like R2 score, the performance. performance is present in between 0 to 1. You can see 0.99, that means it is predicting very high. That is, it is predicting very well. If you want to compare this with a graph, then so with a plot dot style dot context, just provide seaborn context style and plot this data of last 10 records, plot dot plot of. So this y predicted value, I want to see the tail of last 10 records, I want to see. I think the predicted value is not a data frame, it's a numpy array. I want to get the data frame. To get the data frame, just use pd dot, okay, pd dot data frame. To get this data frame from the numpy array and rerun this. So now you can see the plot of the predicted value. Since this is a predicted value, I want to provide a label that is predicted, and actual value I want to see. So that's why I'm using this plot dot plot of y underscore this test dot tail of 10. It will show you the last 10 values with label that is equals to real value. So now, so there will be a mismatches there. Or let's print only the predicted data at first, then let's print again the real data. So I'm just running this. So you can see this is the predicted data that is printed. I want to print I want to print now the original data. So this is the original data, that is this. You can see that I'm importing the same context and I'm taking this TD, that is teaser data, and tail of this, and closing is this. I'm just rerunning this. So now you can see this is the data that we are getting. Or else if you want to see both, so just take y underscore predicted data dot plot. That is a simple method that simply you can able to print that. So you can see this is how the data will be. The only difference between these is nothing but here the date got normalized, so that's why we got like this. Whereas before normalization, this is the date or the result will be look like. If you want to see or if you want to get exactly the dates, then you just replace the dates of this data with exact dates. So that's all about this video. This is a stock prediction with ML, like we predicted the current stocks by using exactly regression based ML model. Here we just find based on the currently available data. But in real time, you might need to predict based on the data set that you are going to create. That is, for now, we considered X, that is input as these all columns, right? Yes. Like opening price we considered, high price we considered, low price we considered, volume, data returns. So these all interest also we considered. But in real time, you are the person need to predict the opening price, high price, low price. And at the end, by using those prices, you are going to predict the adjusting price or closing price. So these prices you are predicting now based on this data set, whatever the data set that I have available, we are predicting this close value and adjusting value, right? Yes. But in real time, you might need to predict the opening, highest and close. lowest values also predicted by yourself only. You need to generate these values as well based on the historic data set that you have. You need to generate this opening high and low values as well in order to predict the day closing value based on the interest or whatever the historic data set that you have. You need to identify this opening high values and low values and closing values in real time. Then only by using this regression based model you can able to predict the closing or adjusting value. Currently for ML, as a part of ML, ML only have knowledge for classification or regression. We just used the regression model to identify these low, these close or adjusting closing values based on the data set that we have. But in real time, these values, let's say for tomorrow or for today, for that is up to 27 it has. For 28, for 28th day, if you want to predict the closing value, then what I require? I require opening value, I require high value, I require low value of today, of today. Then only I can able to use the current model, whatever the model that we designed right now, that is linear regression based model. By using that, we can able to predict this close or adjusting close value. But in real time, how can we able to generate this open, high and low values, sir? We can able to generate these values based on this date by using generative AI applications. ML do not have that capability of generating the data, but AI have the capability to generate the data. So in real time, for prediction of the closing value, you can directly use the AI for doing that, or you can use AI for predicting opening high and low values, and you can use this ML model for predicting close or adjustable close values. So that is all about this video. In this video, you covered the knowledge regarding how to get today's up to today's stock data and visualize that stock data and find the returns, train a model and predict the predict the closing value or adjusting closing value based on the current data set only. For the future data set, if you want to predict, then you need to generate the required fields like high, low, and some other fields. So based on the training data set for your ML model, and by using that data set, you can able to predict the upcoming stock values as well. We have compared the visually the original data set with generated data set as well in this lab. So I hope this video is useful to you. And if you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.